Yeah, welcome everyone. And today we'll be looking into uh, various uh, mathematics questions that were asked in the mechanical engineering discipline for GATE 2024. So we have, uh, uh, you know, uh, after considering the whole question paper, it has observed that there were five one-mark questions considering engineering mathematics in mechanical engineering paper, and there were around four 2 marks questions. So 5 plus 8 is 13. So 13% of your paper was purely mathematics, and I mean maths will be there in other uh, questions also, but purely from engineering mathematics, 13 marks were there. Uh, I mean, and these are like uh, important questions. So uh, let's go and look into them. So, like along with the solutions, we'll study even deeper, or what else could have been asked from this topic. That kind of discussions also we'll do. So let's start with the first one. It was question number 11, and it was single option correct. That kind of question, MCQ question basically. And those who have attended my uh, classes for engineering mathematics, they would realize that we had done this kind of question in our coursework, during our coursework, and there we had mentioned it as a stability analysis for it comes under the numerical methods topic. So this is nothing but related to that uh, concept. So like if you see this type of question for the first time in exam, um, yeah, it won't be that easy. But if you have gone through the stability analysis for a numerical scheme, then this type of questions you can easily tackle, is the takeaway here. So if you look at this, they have given you one numerical scheme, and for solving the differential equation. So let's read the question first. So in order to numerically solve the ODE, dy by dt equal to minus y for t greater than 0. So basically you can consider t as a uh, time coordinate also. So it is a 1D problem with 1D transient problem, you can say. This governing equation is for 1D transient problem, and uh, at t equal to 0, y is 1. Okay, and they have employed a uh, numerical scheme which is given by this equation, where you have yn plus 1 minus y n divided by delta t equal to minus half into yn plus 1 plus yn. Okay, so uh, n represents a certain integer, and n plus 1 is the next time step that you take after delta t time. Okay, so uh, delta t is the time step. Yn is equal to y into n delta t for n integer starting from 0. This numerical scheme will yield a solution with non-physical oscillations for delta t greater than h, and the value of h is. So this question, the first part, or first 90% of the question is just describing the problem, but the main thing that they're asking is they want a condition where you'll get a oscillatory solution for this problem. And in terms of our stability analysis, this is also called as unstable or divergent solution or divergent scheme. So you need to find that critical value of that time step delta t, uh, above which, if you take like bigger time steps than the h value, uh, your scheme or numerical scheme or your solution will oscillate or will not diverge, will not converge. Sorry. Okay, so there are 4 options, and you need to find the correct one. Okay, so as I said, this is similar to what we did in our stability analysis under numerical methods uh, topic discussion. So essentially, since they are talking in terms of yn plus 1 and uh, yn kind of notations here. So for stable solution, for let's say if you have in this scheme, okay, usually we consider one amplification factor. Okay, so solution at n plus 1th time step is equal to some amplification factor. Okay, lambda is amplification factor here. You can use any symbol. Sometimes they use capital E. Here we are using lambda, so it doesn't matter. So for stable solution, this lambda mod of lambda should be less than 1. So in a sense, it means that at each, as you proceed with each time step, your solution value is converging to a final solution. It's not diverging. If lambda is greater than 1 or greater than or less than minus 1, then with each step you are not converging towards a finite value. You are basically diverging or oscillating. Okay, so that kind of interpretation is there. Okay, so now you need to modify this given equation in terms of this kind of yn plus 1 equal to lambda into yn. So basically we need to find lambda. Okay, so let's write down the given equation, which is yn plus 1. 1 second. Yeah, so it is okay. We have yn plus 1 minus yn divided by delta t equal to minus half yn plus 1 plus yn. Okay. So the first step in these kind of problems is to separate yn plus 1 terms on LHS and make all the terms with yn multiplier, take them to the RHS. Okay, so I can multiply by delta t on the both sides. That will simplify things very quickly. So in that case, it becomes yn plus 1 minus yn minus delta t by 2 yn plus 1. I'll expand this bracket also so that you can just plus minus delta t by 2 yn. Okay, so now I'll take yn plus 1 terms on one side and yn terms on the other side. So therefore you'll have 1 plus delta t by 2 yn plus 1 equal to 1 minus delta t by 2 into yn. Okay, so now we are getting somewhere. So here only you can modify. So you can write yn plus 1 as 1 minus delta t by 2 divided by 1 plus delta t by 2 into yn. Okay. So now if you compare, let's say, equation 1 and equation 2, so you can see this amplification factor lambda in the form of delta t in our for our question. Okay, so therefore you can write the amplification factor for our numerical scheme given in the question is 1 minus delta t by 2 1 plus delta t by 2. Okay, so now for stable solution, the scheme needs to be within certain bounds. So essentially they call it as a bounded amplification factor kind of thing for stability. Okay. So one thing you could notice here is okay, so we'll just solve it. I'll tell you the interpretation. There are some nuances here because so far they have asked just direct questions on stability. This one has one additional layer of information that you should know. Okay, so for a stable solution, your lambda must be strictly within 1. Okay, so that means or you can write it in even more simple manner, which is lambda value should be between 1 to -1 or -1 to 1. Okay, so then you put the lambda definition here. Okay, so in our problem it will transpire to this kind of inequality, okay, for stable solution. Now let's say you solve each inequality separately. So if you solve this part of inequality, what it gives you is 1 minus delta t by 2 should be less than 1 plus delta t by 2. Okay, so the solution for this inequality is delta t. Actually there is no solution because when you subtract 1 from the both sides, it's just minus delta t by 2 less than delta t by 2. So it should not be no solution. Actually there is no unique solution in this case because you can take delta t value as anything and this inequality will be satisfied, right? So here you will not get unique solution, so that doesn't help us. What if we solve the second part of inequality, which is this part? So if you do that, you'll get -1 minus delta t by 2 should be less than 1 minus delta t by 2. Okay, and this is actually, again, there is no unique solution here because -1 will be always less than 1 for any value of delta t that you choose. So here also no unique solution that you can get for delta t. Okay, so this is what I was saying. So far they had not given such kind of numerical schemes or numerical method schemes, but this time they had given one additional layer of complexity. So in such cases, what you need to do is you need to check whether, like, this lower bound you need to take it to 0. So what that means is your amplification factor is between 0 to 1, right? So that means it's always positive but smaller value of positive. So with each step you're getting closer to the solution. So in such scenarios when you don't get clear answer by following the stability condition, so in that case what you can do is you can upgrade your lower bound from -1 to 0. Okay, so in such cases you need to check this one. Okay, so since 0 is on the one side of inequality, denominator will be ineffective here, or it will become 0. So this becomes delta t by 2 less than 1. That becomes delta t should be less than 2. Okay, but this is for stable solution, okay, condition. But if you go back to the problem, they are not asking us to find the stable solution condition. What they are asking us to find is non-physical oscillations. So basically unstable condition. So since if you choose delta t less than 2, you will get stable condition or stable solution scheme. So okay, 1 second. Okay, so for this unstable yeah, unstable or oscillatory solution. The necessary condition should be delta t should be greater than 2. Okay, greater than or equal to 2 also is fine. Okay. So if you look at the various options that are given in the question, first is half, second is 1, 3/2, 2. So therefore, uh, you know, option D is correct, where your option says delta t. I mean, it says h equal to 2. So basically delta t greater than 2. Okay. So I mean, uh, like this like exactly at 2 what happens. You can like it is actually a dicey area. So in some books you'll see this inequality they put something like this. So all the way uh, you'll see this kind of thing. So if you keep it at 2, it will be stable, but if you slightly increase above 2, it will be going to the uh, unstable region. So maybe this question paper setter has followed that type of scheme, but you'll see both the things. So that is why usually at the boundary it's dicey. Okay, but in this question there are no other options which are greater than 2, so therefore there is no confusion here. Okay, so I hope it is clear. So it is basically stability analysis, but the extension of it this time. Okay, because from the standard stability analysis condition you are not getting any unique solution for delta t, so you need to increase the lower bound to 0 so that your amplification factor doesn't change sign. Okay, so therefore you will not have any oscillations. Okay, so that was about it. Now let's go to the next question. And in the next question, you know, it's basically you need to find a surface integral. Uh, for a closed surface denoted by S, and S is nothing but external surface of the sphere, which is given by the equation x square plus y square plus z square equal to r square. Okay, so uh, this is a sphere, closed spherical surface, and along this surface you need to find the integral of z into dx dy. Okay, and there are 4 options. It's also MCQ question, one option correct kind of question. Okay. So these type of questions also we had done in our vector calculus. So and in previous year gate questions, gate exam questions also you'll find many of such questions. So if you had done that, it will be good for you. Okay, so it's basically in this question, but just by looking at it, I can guess that since we are talking about closed surfaces, this Gauss divergence theorem would come handy in this kind of situation. So what is the Gauss divergence theorem? So basically Gauss divergence theorem, it connects closed uh, surfaces to the volume occupied by those closed surfaces. Okay, so since they want us to find the surface integral, that should be equivalent, and since this is a closed surface, it bounds a closed region in R cube space. So in that case, if you convert it into volume integral also, it should be same, or it should give the same answer because of Gauss divergence theorem. Okay, so Gauss divergence theorem states that like if you have a closed surface integral, so let's say you do this, you have a some function f vector function, and then you take its dot product with the surface elemental area, and if you apply the limit of integration along the closed surfaces, it is equivalent to calculating the volume integral for the divergence of this function f, vector function f, and elemental volume, so that you are doing volume integral. Okay, so if you look back to the question in hand, here you can see this f function is nothing but z into k cap. Most likely it will be like that, and this ds is nothing but dx dy. So basically, I mean, you can write this I dot cap and j dot cap. That's fine. But the point is, basically in xy plane, if you draw a certain xyz plane, what this integral is representing is there will be a small dx and dy elemental area, which is represented by dx dy, and then you take the height from that element, okay, up to the surface S, and then basically you are integrating the whole volume. Okay, so if you understand that way, then also you'll understand that basically you are calculating the volume of a sphere here. But if you don't relate to the physical interpretation, if you are just going by mathematics, that is also fine. If you just use the Gauss divergence theorem, so here f is nothing but z into k cap. It's a vector function. So if you take the divergence of f, it will be nothing but basically it will be del z by del z only, because there are no other two terms, right? So divergence, you take component wise multiplication, differentiation, partial differentiation, right? So there is only k component, so you take the partial differentiation with respect to z, and there is only z, so it is 1, and therefore this volume integral of your 1, because divergence of f is 1 into volume, is nothing but volume of a sphere of radius r, because the surface given in this question is nothing but a spherical surface. Okay, I mean the surface is bounding a 3D sphere. Okay, so that's why volume of the sphere is 4 by 3 pi r cube. Okay, so therefore the solution for this problem is 4 by 3 pi r cube, which is nothing but option C. Okay, so there are two ways to do this. One is mathematical way, if you know the Gauss divergence theorem, and second is just you can, since the function was easier here, z into dx dy, you could have collected it to the geometrical interpretation also. But geometrical interpretation won't be possible in all the choices for f. Okay, so if f is very complicated function, you can't do it geographically, then you have to resort to direct mathematical Gauss divergence theorem applications. Okay, so it was a straightforward question, and this type of questions are asked multiple times also in mechanical or related fields. This Green's, Stokes, Gauss divergence theorems, these are very important. Okay, many like almost every time they ask questions on those things. Okay, so let's go to the third question, or question number 13. So this was interesting question because again this time they added one more layer of complication, but you could have guessed the answer. Okay, we'll discuss about that just in a minute. So let's read the question. So let f of z be an analytic function. Okay, so you should remember what is analytic function. So analytic function basically satisfies CR conditions or Cauchy-Riemann conditions. And what they're saying is this real part of this function is directly given as cos hx plus cos y, and the imaginary part of f of z is 0 for y 0. Okay, so many students may read this incorrectly, so they may think that imaginary part of f of z is 0. So that means there is no imaginary part, but they have given that it is only 0 for y equal to 0. So that is very important condition there. Okay, so then you need to find the f of z. What is the nature of f of z? Okay, so we have done similar questions multiple times in complex functions or complex variable classes. Basically, for analytic function, if you let's say let your f of z be some u which is function of xy plus I into v of xy. So this is a standard procedure that we do. Here they have given the real part, which is u, which is directly. So here your u is directly given as cos hyperbolic x into cos y, and this part is unknown. What is the v function, that is unknown, but we know that if you put y0, this function value should be 0, v value should be 0. Okay, so that is the known part. So and this very important analytic function condition is there, so you just have to use the CR conditions. So CR Cauchy-Riemann, I am not writing the full form, you should know this. Cauchy-Riemann conditions for analytic functions, and you are supposed to remember this. Okay, it will be ux equal to vy and uy equal to minus vx. So here ux means partial derivative of u with respect to x is equal to partial derivative of v with respect to y, v with respect to y, and similarly here del u by del y is minus del v by del x. Okay, so you have to use these two conditions to get the form of v. Okay, so start with any one. So we know that u is cos hyperbolic x and cos y. Okay, so let's start with the first one. Let's say you calculate del u by del x. Okay, so maybe we'll make a partition here so that we can solve two parts like this. So now cos hyperbolic function differentiation you should do, because cos y is constant with respect to x, so it remains as it is. See, cos hyperbolic x, that is the tricky part here, because it's we usually don't deal with the hyperbolic function, so you may not remember the differentiation of cos hyperbolic, sin hyperbolic, like those functions. Okay, that is okay, but you could be smart. So cos hyperbolic is e to the power x plus e to the power minus x by 2. Okay, so you can differentiate that function, and that just gives you sin hyperbolic x, right? So what I mean is you should use this definition of cos hyperbolic x function, cos hx. Okay, so that then you differentiate, you get e power x minus e power minus x. That is the definition of sin hyperbolic. So you get sin hyperbolic x here. Okay, and this will be equal to del v by del y because of this CR condition, and then you integrate basically. So integrate with respect to y. So v will be integration of this sin hx cos y dy, but it is a partial integration. Okay, so you should remember that, and then you'll have some function of x here. Okay, so Now you need to treat sin hx as constant, and cos y is there. So sin differentiation of sin is cos, so cos integration will be sin. Okay, so therefore you get v as sin hx remains as it is, and you get sin y plus some function of x that is unknown. Okay, so now to find this unknown function of x, you need to use in this question it is easier because they have given you this condition, okay, that if you put y equal to 0, you should get v of x comma y, that is the imaginary part of your f of z, as 0. Okay, so we know v of x comma 0 is 0. So that means you need to put y equal to 0 in the v expression. So y 0 sin 0 is 0. So that gives you f of x as 0. Okay, so therefore the form of the function v is nothing but sin hx into sin y. Okay, and therefore your f of z is nothing but cos hx cos y plus I sin hx sin y. Okay, I'm just writing u and v. This is nothing but u plus iv form. Okay, so now the tricky part here is, even after this, the options are not straightforward. If you go to the options, see, first two you can eliminate because there is no exponential part in the final solution. The confusion is between these two, C and D. See, here also you can eliminate C because uh, there is no separate cos y term in our final expression for f of z. There is no separate y term, cos y term. Okay, so there is one cos y here, but there is no cos y on this side. So that way also you can eliminate, but there is a formal way to do this. I'll do that, but I'm saying in exams you'll not always have luxury of doing this formal solutions, right? So there you need to be smart. So first two options you can eliminate because there are no exponential functions in the final form of f of z, and or even this exponential minus iy, all those things. They also, if you expand, that will have cos and sine terms, right? Something like that. So there is no sine hyperbolic there. So that way you can eliminate first two options. And C option also you can eliminate. My point is, I will give you the formal proof of correct answer, which is option number D. But I'm saying in exam, you can't do this way. It will take a lot of time. So you should be good with the elimination technique. Okay? So that way you reduce your effort significantly because in exam you have limited time. Okay, so that was the point. Okay, so once you get some idea about f of z, you can start eliminating the options because this is not the direct solution that you can have. So one thing that you should wonder here is, in all of these options, let's say B, C, D, they are talking about cos hyperbolic z. Okay, so let's see what it means, because one of the option is cos hyperbolic z itself. So let's take cos hyperbolic z. Okay, and here we are talking about z will be x plus iy, right? It is given in the problem. So it will be very unusual. Unrealistic for me to ask, do you remember the cos hyperbolic a plus b formula? Because nobody does. You remember cos, sine, tan, those things, but hyperbolics are usually not mainstream. That mainstream. And nowadays I have seen they are asking about hyperbolic functions. I don't know. Maybe they have fed up with the normal trigonometric things, so they are going into hyperbolic functions more now. So maybe going forward, you should prepare more about them also. Nonetheless, here you can do certain tricks, and let's say Again, we know the formula for hyperbolic functions, right? It is e power x plus e power minus x by 2. So here x is nothing but x plus y by x plus iy. Okay. So now you just expand this. So this cos hyperbolic z, it becomes e to the power x into e to the power iy plus e to the power minus x into minus iy by 2. Right? I'm just doing a straightforward this thing. Okay, it's like property of powers. Okay, so now we know that e to the power iy is nothing but it will be cos y plus I sin y. Similarly, this side you will have cos y minus I sin y. Okay, only the sign becomes negative, divided by 2 remains there. Okay. So now what I'll do, I'll take cos terms together and I'll take sin terms together. So let's keep this half as it is. Then let's take cos y terms, whatever are there. So it is e power x is there, plus e to the power minus x is also there. Maybe I should write slightly down, otherwise it will be confusing. Okay, so let's take cos y terms, e to the power x plus e to the power minus x by 2. Okay, and then let me take I sin y terms here. So in that case, you have e minus x by 2. Okay, so cos y to cos hyperbolic x plus I sin y into sin hyperbolic x. Okay, this is actually identity of cos hyperbolic functions, but I mean, we don't study these things. Not required, because these type of questions were not asked in the GATE exams before. Okay. Anyway, so now you should compare your, let's say, equation star, which is your f of z, and let's say equation square, which is cos hz. Okay, so from equations star and square, you can see that your f of z is nothing but cos hyperbolic z. Okay, and that is your option D. So this is a formal derivation because there was no time pressure for me to solve this question formally. But practically speaking, in exam, if you get this kind of question, first of all, I mean, if you have less time, you should skip this kind of question, because it is anyway negative mark question. But if you have some time that you can spare, because see, if you have attended my classes, you'll reach up to this step. Okay, but from here to deduce that it is cos hyperbolic z, that's that takes some smart. Okay, so then you have to go to the elimination technique and eliminate first 2-3 options. Okay, but yeah, I mean, it was one of the tough questions. Okay, but yeah, the answer is option D, and you have formal derivation like this also. Okay, so yeah, this was about question number 13. It was an interesting question, one of the difficult ones. Okay, so let's look into this one, which is question number 14. And again, this type of question is also asked in previous years. So as soon as you see this kind of keywords, okay, so they have given you a system of linear equation with 3 equations of x, y, z, and you need to find 2 unknowns, a and b, and they have mentioned that for find such values of a and b for which you'll have infinite solutions. And just to confuse some students, they have given this term which is called as non-trivial null space. I mean, this is also a mathematical term, but Like if you don't know this, still you can solve the problem if you remember the conditions for infinite solutions for system of linear equation. Null space, we discussed this briefly in class, is also called as kernel. For any matrix A, it is set of vectors which satisfy the condition Ax equal to 0. Okay, and this x vectors, all of its element cannot be 0. Okay, so otherwise that's a trivial solution. Okay, so that is called as null space, and this non-trivial null space exists if the matrix is singular. Okay, so in this case it will be a coefficient matrix. So if you know that definition, good for you. But otherwise also that infinite solution condition is also good enough to solve this problem. And this type of problem was asked previously. I remember, I forgot which year, but similar problem was there. Okay, so if you had solved previous year questions also, you could easily score these numbers. Okay, so I mean that's off the topic, but solving previous year questions is highly recommended for these kind of questions or incidents. Okay, so let's see. We know that for infinite solutions, I'm not writing the next part, which is for a system of linear equations. The necessary condition is rank of your coefficient matrix should be equal to rank of your uh, augmented matrix, and it should be less than the uh, number of unknowns in your system. Okay, so sometimes they call it number of columns or number of unknowns, and here it is 3. Okay, so what is your augmented matrix? Here is nothing but matrix A, which is the coefficient matrix. So 1 2 1 2a4 2 4 6, 1 2 1 2a4 2 1 6, and B is nothing but the RHS things. So 5 12 B. Okay, so here you have two unknowns that you need to find. One is A, one is B. Okay, and for this rank of this matrix should be less than 3. So it can be 2, it can be 1, anything. So you need to do some elementary operations to make this rank calculation clear. Okay, so can do certain operations. So let's make these elements 0. Okay, so you can do R2, transform it to R2 minus 2R1. Similarly, R3, transform it to R3 minus 2R1. Okay, so if you do that, the first row remains as it is. We are not touching it. So let it be. This becomes 0. This becomes A minus 4. This becomes 2. This is 2. 0. 1 second. Did I do anything typo or something? Let me just check. 1 2 1 2a4 2 4 6. It is 4 here. Yeah. So then 4 minus 4 0. This will be 6 minus 2 4, and here it will be B minus 10. Okay, so now this condition where this rank of A also has to be less than 3. Okay, so that is possible only if from here you can say let's say if A is equal to 4, then what happens? Your second row becomes 0 0 2. Okay, so second, maybe I should write it slightly clear. Okay, so if A is equal to 4, then second row becomes 0, 0, 2, and in that case your second row becomes dependent or linear multiplier, linear you can obtain third row by multiplying by 2 to R2. Okay, so they are linearly dependent. So in that case, you get rank of your coefficient matrix as 2. And if B is also equal to 10, so this part I'm talking about now. So in that case, what happens? No, it cannot be 10. It should be 14, right? Because okay, we'll take one more step and then you'll understand what I mean. So let's take A equal to 4. In that case, with A equal to 4, you have 1, 2, 1, 5, 0, 0, 2, and this side also 2, if I'm not wrong. Yeah. Then you have 0, 0, 4, B minus 10. Okay. So now you can do, one more operation wherein you change R3, and how do you change it? You subtract 2R2 from this. Okay, so then you get 1, 2, 1 remains as it is, 5 also remains as it is, 0, 0, 2, 2, this becomes 0, 0, 4 minus 4 is 0, and this becomes B minus 14. Okay, now you see rank of your, you just see this, rank of your A matrix is 2, and therefore for a consistent system, you should have rank of your augmented matrix also equal to 2, and that will happen only if B minus 14 is equal to 0. That means B should be equal to 14. Okay, because if B is not 14, then the system will be not consistent, because rank of augmented matrix will be 3, and it will not have infinite solutions. It will not have, it's not a consistent solution system of equations only. Okay, so therefore the solution is A equal to 4 and B equal to 14. Okay, so these are two solutions. So if you check the options, yeah, this one should be correct. A equal to 4, B equal to 14. Okay, so this is how you solve these kind of questions. You should always pay attention to what they're asking: infinite, unique, or no solution. That three cases are only the possible cases in this type of problems. Okay, so we have also done similar problems on number of occasions in our classes, regular classes. Okay, so that is about question number 14. Let's look at question number 15. Prima facie this question looks pretty scary, and I get it, because especially if you are from mechanical or aerospace background, or similar to mechanical backgrounds, you study this maxima minima conditions for function of single variable, and that too from a calculus point of view. But if you have interest or just curiosity, the CS people, computer science or ECE or EE, sometimes they study these maxima minima conditions from matrix point of view. So basically, it is a standard definition actually. This question, if you know, there is no, you'll not require even 5 minutes to solve this. But if you are scared about these notations and all, then yeah, it is not that easy, not because it's the difficult question. It's just that we don't study the same concept in this form. for mechanical or aerospace courses. Okay, so nonetheless, let's see. So they are saying it is a twice differential function f which maps R2 to R. So it takes two inputs and gives one output, one real output. And this is your hint. Okay, so they are saying P and X naught are R square. So that means these are vectors. Okay, 2D, two-dimensional vectors. Okay, where Euclidean norm. Okay, so or distance. So these if you see these kind of things for the first time, you'll be quite taken back. Okay, but nothing to worry. This is like a in our limit definition we say no, we take a small neighborhood and we check the limit in that neighborhood. Similar thing they are doing. They are just explaining it in terms of vector notations. Okay, and this is it is nothing but Taylor series expansion of your f of x naught, f of x around x naught, and smaller distance of around with a radius of smaller distance p. Okay, and yeah, so what they're asking in the end is, see these things and all not relevant, because this is classical definition. If you know psi, that is phi. If you don't, that is also fine. But what they're asking is, if x naught is a strict local minima of f of x, then which of the following condition should be true? Okay, so let's leave this kind of notations aside, because these are all matrix or vector form of representations. But let's talk about in general. In general, what we know for x naught to be local minima of f of x, there are two conditions that it needs to satisfy, right? One is f dash of x naught should be 0, and the second derivative should be greater than 0, right? First derivative should be 0, which is called as critical point, and if at the same point, if the second derivative is positive, that means it's a local minimum. Okay, so you should compare these two conditions with the conditions in the option. Okay, because sometimes you need to improvise in your exams. You'll not get everything in the standard form that you have studied. Sometimes you need to improvise. So how do you improvise? So you see on these all the options, they are talking about gradient of f of x naught transpose p. Okay, so basically it resembles our first condition, which is the first derivative of f of x at x naught should be 0. So they are taking, instead of derivative, they are taking gradient. Okay, and if you remember, derivative is in one directional, but gradient will have multi-directional component. Okay, so if you take gradient in single dimension, that is nothing but derivative. Okay, this much we have already discussed. So basically, if you don't know anything, in that case, this grad f of x naught tp resembles f dash of x naught. Okay, so and it should be 0. Okay, so you should improvise like that if you come across such statements, because it's the same thing, it's just expressed in the different notations. Okay, so you can clearly eliminate this option because all three are saying it should be equal to 0, and this one option says greater than 0. Okay, and if you look at this second dangerous looking term, which is nothing but p transpose, this is called as Hessian of your function. It's not x naught here, they are calling it as psi here. P, it should be greater than 0, right? for a local minima, because it resembles our second condition where it should be greater than 0 for local minima at x naught, right? So even if you had done this much logical reasoning, you would have gotten the correct answer, because the answer is option number B only. And if they're asking for maxima, then option number D would have been correct. Okay. So I mean, it is valid to skip if you're not confident enough. But this question was not that difficult. It's just that we as a mechanical engineers don't study in this fashion. But if you are from CS background or maybe related to that, it's a standard definition actually. So there is nothing more to explain. It's just the way of looking at things. We look it from the differentiation point of view. They look it from the gradient or Hessian point of view. So this is called as Hessian matrix. There are different properties also. If it is a positive definite, then it will be minima. If it is a positive negative definite, it will be maxima. All those things are there. You basically calculate eigenvalues and all those things there. Okay, so this was one of improvisation kind of question. If you would have done that, you would have easily scored. Otherwise, if you skip this one, that also I agree, because there were a lot of bunch of things that we usually don't see. Okay, so anyway, let's go to the next question. Yeah, so this is a standard question. They are given you a 2 by 2 matrix where A is a positive number. I mean, I don't know what is A. It is an integer or fraction. We don't know. It's just a positive thing, and it should have negative eigenvalues for what value of A, or what value of A is higher than certain limit. So I mean, this is a standard question. So here what you need to do is you need to first find eigenvalues. Eigenvalues of A, and we have done this multiple times. You need to 1 minus lambda A 8 1 minus lambda. Okay, you need to take determinant of this matrix, and here it is 3 actually. Okay, so there will be a quadratic equation in lambda. So I mean, it will be 1 minus lambda 3 minus lambda minus 8A equal to 0. Okay, so if you further simplify, basically you get lambda square minus 4 lambda and plus 3 minus 8A equal to 0. So you need to find lambda. This is a quadratic equation. So we know how to find the roots for such equations. So that will be minus B. So this becomes plus 4 plus minus B square minus 4AC by 2 into 1, because A is 1. So what I can do here is I can just take 2 common from the numerator and denominator and cancel it out. So in that case it becomes 2 plus minus you take 4 common, right? So here you'll remain with 4 minus 3 minus 8A. Okay, so that essentially means 2 plus minus 4 minus 3 is 1 plus 8A. Okay, so these are your 2 eigenvalues. So what they are saying is, in the question they are asking you to find a certain condition on A such that it should have negative eigenvalue. Okay, so from these two, and since A is greater than 0, the square root will be always positive. So the chances of having negative eigenvalue the higher probability
You are currently the only person in this conference.
Yeah, higher probability of negative lambda will be for, because if you have plus sign, it will never be negative, right? So yeah, actually not higher. It should be, if you want negative lambda, the only possible case will be the eigenvalue will be negative for lambda equal to 2 minus 1 plus 8a, and it has to be negative. So in that case, so you need to solve this. So basically 2 less than 1 plus 8a, right? So you can square it, then it will be 4 less than 1 plus 8a. So it will be 3 less than 8a. Therefore, a needs to be greater than 3 by 8. And this is your answer. Okay, so I think it's option A. Okay, so this was one of the easier questions, I would say, because it's a standard procedure. You just make sure that you don't do any calculation mistake, and since they're asking for negative eigenvalue, that is only possible when you have 2 minus under root 1 plus 8a condition, because a is greater than 0, the square root is always positive, and if you add 2, that will be always positive. So that will be positive lambda. They are talking about negative lambda, so you take 2 minus square root wala thing. Okay, so that was about that question. Then you have this question of double integral. So again, it is what we have done a lot of times. So there are two ways to solve this. You solve the inner integral, which is y limits. So you treat x as constant, and then you solve it. Or otherwise, you can do some substitutions also, just to simplify your life. Okay. So we'll do the substitution one, because otherwise sometimes students get confused. Okay. So this one, you can write x equal to 3 to x equal to 4. Let's do the inner integral first. Y equal to 1 to 2 dy yx plus y whole square into dx. So we'll do with respect to y first, and then we'll put it in as a second integral with respect to x. So let's solve for I. So you need to solve for I, where y goes from 1 to 2 dy x plus y square. Okay. So just to simplify everything, just put this as x plus y. So here, since the integration is with respect to y, x is treated as constant. So you'll have dt equal to dy, and when y is equal to 1, t becomes x plus 1, and when y is equal to 2, t becomes x plus 2, because your limit of integrations will also change. So this will become x plus 1 to x plus 2, and you'll have dt by t square. Okay, so t power minus 2. So integration will be t power minus 1 by minus 1. So essentially you'll have minus 1 by t going from x plus 1 to x plus 2. Okay, just to get rid of that minus sign, we can reverse the limits. So it will be 1 by t x plus 2 x plus 1. Okay, so therefore your I will be 1 by x plus 1 minus 1 by x plus 2. Okay, so that is half of the question. Okay, yeah, and then just put this I in your bigger integral or the outer integral. Therefore you need to do what you need to do is x equal to 3 to x equal to 4. You need to put x plus 1 minus 1 by x plus 2 dx. Okay, and this is nothing but ln x plus 1 minus ln x plus 2 going from 3 to 4. Okay, you can write it as ln x plus 1 by x plus 2 going from x3 to 4 also. So in that case, if you put 4, then you have ln 5 by 6 minus ln 4 by 5. I hope everything is correct here. 5 by 6 and if you put 3, 4 by 5. Okay, yeah, so then you can use ln property. You can just reverse the next second one. So this becomes 5 by 4. So then you multiply both the terms. So this becomes 25 by 24. Okay, yeah, and then just compare with what they are asking. So they are asking that final answer should be ln a by 24. So if you compare this with ln a by 24, what it gives a value should be 25. That was your answer. So again, simple or straightforward kind of question. You just have to do the one integration with respect to one variable first, then put it into the outer integral. Okay, so done. We have done these kind of numerous problems, so there is nothing difficult here. It's just that don't make any calculation or any sign mistake, because if you do, then everything will be wrong, because it's a data entry type of question, I think. So you don't have options also to corroborate. Okay, and then you have this differential equation ODE, where you have t as the independent variable, x as the dependent variable. Okay, and you need to they have given this as t into dx by dt plus t minus x equal to 0. Initial condition is given that at t equal to 1, x was 0. Then you need to find the value of x at t equal to 2, rounded off up to 2 decimal places. Okay, so just by looking at it, it looks like the candidate for integrating factor kind of thing, because you can just divide the whole equation by t here itself. So what will that give you? Dx by dt plus t minus x by t equal to 0. That itself is further simplified as dx by dt minus x by t equal to, let's say, 1, or it will be minus 1 because we are putting it on the RHS. And if you compare this with our standard form, where you can write dx by dt plus some function of independent variable into x, some function of independent variable. Just make sure you don't get confused between x and t and x and y, because usually we study xy. Here they are talking about xt. Okay, so in that case, you can write this p of t as minus 1 by t, and q of t is minus 1. And then you can, find integrating factor. So integrating factor is nothing but exponential of p of t dt. Okay, so p of t is minus 1 by t. Let's take minus 1 outside. So integral of dt by t, that is ln t. So it is nothing but minus ln t. Okay, so that is nothing but 1 by t, because minus will be power of t. So 1 by t, and then e power ln 1 by t just becomes 1 by t. Okay, and then what you need to do here is, if you remember the that direct formula, usually I forget that thing, but let me just check. Yeah, so yeah, basically you multiply by this integrating factor to both sides of the equation. So here what happens, if you multiply by 1 by t on the both sides, because there is a direct formula also, but I don't remember that, so leave it, it's not required. If you just remember the procedure, so this becomes 1 by t into dx by dt, and the second term will be minus x by t square, and there was minus 1 here, right? So this becomes minus 1 by t. And if you look at this, this is actually a exact differential of x by t. This is nothing but d by dt of x by t, right? Yeah. So then you integrate on both the sides with respect to dt, and some integration constant will that will come in the next step. Okay. So then this becomes just x by t on LHS, and here it is t power minus 1, right? So ln t, so minus ln t plus c. Okay, so your x will be minus t into ln t plus c t. And now your job is finished. You have the formula for x. It's just that you need to use the initial condition, which is at t equal to 1, x was 0. So at t equal to 1, x was 0. So that means 0 equal to ln, this is minus 1 into 0 plus c. So that means c is 0. Okay, so therefore x is nothing but minus t ln t. And finally they are asking x at t equal to 2. So therefore x at t equal to 2 will be minus 2 ln 2. Okay, so ln 2 is 0.693, and if you multiply it by 2, it will be minus 1.386. So this was your final answer. And they were telling you to round it off till two decimal places. So it will be minus 1.39. I hope you remember how to round off. That is also important for these type of questions. This was also another straightforward. You just needed to identify it's a integrating factor method question. Once you do, then it would have been easier. Okay? Just you should not make any calculation mistake. That's all. And this I think is the final question. So here you have x, which is a continuous random variable defined over 0 to 1 support, such that its probability density function, we usually call it as PDF. For discrete random variable, it is PMF. For continuous random variables, it is PDF. It's actually a constant PDF. Okay. So between 0 to 1 of x values, there is a probability, equal probability of, so basically it's a uniform, continuous uniform random variable is there. And outside this 0 to 1 limit, it is 0. Okay, that is fine. Now they are defining y as ln x plus 1, and they want expected value of y. So basically, they are asking you for expectation of y. Okay, so this problem is easier because of the thing that they are asking. If they are asking for expectation, the beauty of expectation is it's a linear operator. Okay, so what I mean by that is, let's say if they are asking you to find expectation of x, let's say here they are asking for y, but let's say if they are asking for x, then how do you do? It is 0 to 1, because it is only non-zero in this region. Then you multiply x with the f of x, right, dx. So maybe I should write small x here. Okay, and since it's a linear operator, if I replace this x with some another function of random variable x, it still holds the same. It's just that it becomes g of x into f of x dx. Okay, so there is a mathematical proof to it. It's not like you know just we are taking inside. But the basic idea, you can refer to any standard book. But the basic idea is this much only, that since this expectation is a linear operator, that's why you can just take inside. Okay, so whatever is the function of uh, initial random variable or the base random variable, which is x here, you can just take that inside and multiply. Okay, so here, once if you remember this, then your life is easier, because then you can just write here the function of x that you define, which is g of x, is nothing but ln x plus 1, right? So therefore expectation of g of x is nothing but in this context it is also called as y, so it will be 0 to 1 ln x plus 1 dx. Okay, so here you should write small x, and now it just becomes a integration problem, and it's not a difficult one. You can solve it. It's basically UV rule. Okay, so uh, here what is U and what is V? You have to remember the eyelet conditions. Okay. Okay. So one second. So So here the thing is, it's a standard result also, but if you don't know, this u integration v dx minus one second. Yeah, I think u integration v minus the whole integration of du by dx. One second. Oh, correct only. I don't know why I doubted. Anyway, so v dx. Okay. So here the only trick is choose ln x plus 1 as u. So u, choose it as ln x plus 1, v as 1, and it's a very standard thing. So I'm skipping some steps here because anyway we are running late also. But if I'm not wrong, one second. So okay, we'll do it. Anyway, 2-3 minutes only it will take. So therefore, ln x plus 1 dx, u will be ln x plus 1 as it is. Integration of v will be x minus actually we'll apply the limits at the end. Okay, so let's not complicate here. So this will be 1 by x plus 1 into x dx. Okay, so what you can do here, only you can add 1 and subtract 1, so that this term becomes 1 minus 1 by x plus 1. Okay, and then you integrate this one. So therefore, integration of ln 1 plus x dx is nothing but x ln 1 plus x or x plus 1 first term minus integration of dx will be x, so that will be minus x. Okay, and plus integration of 1 by x plus 1 will be ln, plus ln x1 plus 1 plus some c. Okay, but since we are doing definite integral between 0 to 1, that c we need not worry about. Okay, so here so if you put 1 upper limit, so this will be ln 2 minus 1 plus ln 2. Okay, and if you put 0, it is all 0. So basically it will be 2 ln 2 minus 1, if I'm not wrong. Let me just check the answer. Yeah, the final answer is 2 ln 2 minus 1. Okay, so therefore again you need to remember ln 2 is 0.693. If you multiply it by 2, it will be 1.386, then minus 1, so 0.386. Okay, and you need to round it off to 2 decimal places, so 0.39 is the answer. Okay, so this is the correct answer. So it actually they framed it as a PDF question or probability and statistic question, but it was actually an integral question. It's just that you should remember you should have remembered this property of expectation. Since it's a linear operator, you can just take any function of x and integrate inside the PDF. Okay, so basically we do same thing for e of x square that comes into the variance calculations. So okay, so that is the same logic. Instead of x square, we are taking ln x plus 1 here. Okay, so that was one thing. Another thing that could have been asked, which is not asked here, but it could have been asked, is um, let's say that you have new variable now ln x plus 1. So what will be its new PDF or probability density function for that new variable? So that kind of question can be asked. So in that case, you need to do what you need to do. You need to define y as ln x plus 1, right? So it will vary from x is going from 0 to 1. So y will go from 0 to ln 2, correct? Because ln 1 is 0. So if you are shifting everything to y domain, so that will be 0 to ln 2. And then you need to find this what do you call this CDF for y, cumulative distribution density function, cumulative density function, and then you need to differentiate to get the probability distribution probability density function for y. So that is a standard way to do this. They have not asked it here, so we are not doing it, but I'm just telling, maybe next time they could ask, who knows. Okay, so just keep that in mind. That kind of questions can be framed. If they're asking about PDFs for y based on PDF of x, there is something called as transformation theorem also. So wherein you can just shift PDF of x into PDF of y by multiplying derivative of dx by dy also. So those things are there. We usually discuss these things in regular classes, so maybe not today, but just keep that in mind. There are different questions that can be framed for this type of problems also. Okay, so with that, I think we have covered all the questions for this discussion. Yeah, so then we'll stop for the day, and see you next time. And uh, just like from this class, takeaways, just like, see, you can find these solutions anywhere, but the idea is, what if you are facing these questions in exam environment, and so what they could ask next time, okay, and where they are going, because nowadays they are asking for hyperbolic functions and all those things, so you should prepare for those things next time. Okay, so with that, I'll close the discussion, and maybe we'll have some other discussion for other disciplines. Okay, so see you next time. Bye. Good night.
You are currently the only person in this conference. You are currently the only person in this conference.